Okay. Ashwita, good evening. Everybody, good evening. We'll start our refractive index final revision. Okay, Mahalakshmi, good evening, beta. So we are starting our session. Please get ready, everyone. Yes, for others, this session is going to be important because you people have to finish your work. You people have to write down the contents and keep it. My voice is audible. Now look here, we are going to discuss about refraction in this session and content related to refractions. Join the session as fast as possible. So now look here. Yes. So now get ready for the class, please. So in refraction part, we must understand that refraction is a bending phenomena. Understood or not? Means Ritujan, good evening. Darshini, can anybody inform Sanjay, Veda, everybody, please listen me carefully. Okay. Now listen, everyone. Today, 2-3 sessions will be there. Listen carefully. So in the today's sessions, what we are going to do is first refraction we are going to understand. After that lens we are going to understand. Then immediately we will start solving questions related to it. Understood? So after that, because we have only 2 days left for our maths, our strategy lesson first. So today I am giving you the strategy wise what and all we are going to do work. So that strategy everybody note down. So when and all we are going to do what and all work. Got it? So today, tomorrow is a very lengthy day for us. Maybe tomorrow I'll not go school. Tomorrow nearly 5 to 6 hours classes will be there because there I'm going to discuss magnetism. Because for science, like we have very less day for science examination, got it or not? In between also I will keep 1 or 2 science classes. Understood or not? So because we don't have time, so one hour science practice in night 10 to 11 o'clock we will be keeping. If other exams are also there means 1 hour at least we will prepare for examination. Got it? Because science is a major target. So now can you tell me the dates for your examination? The first examination date is 17th of February. So 17th of February is maths, which is our massive work is pending for this. Today is 3rd February. Okay. After that, next examination is science. So science is 25th. Everybody pay attention here. Science is 25th February. Understood? So 25th February, we are getting how many days gap for science?
21st English, ma'am.
See, 21st is English.
7 days. 21st English. 23 for them Tamil example.
21st English. After that,
23 Tamil example.
23rd Tamil is there. And
Then
Hindi?
Hindi.
25th is science. Those who are having Hindi one day, when they are having Hindi, I don't know. But please pay attention here. So here 17th is maths. Now this part 21 to 25, we have Tamil exam in between. We can't disturb the student. So only 1 day gap is there. 1 day gap is there. Okay. So now what we are going to do here is everybody pay attention. Our what format we are going to use. I'm explaining everybody. Now 14th of like 17th part is there. Na? So we have total revision days. How many revision days when we are going to start maths work? Sanjay, look here. Everybody please pay attention. 17th is maths. We are starting maths from 7th. 7th Feb we are starting maths. Full on revision of maths without break. Understood? So 7th we are starting maths. 7th will be full day. 8th will be full day. School exams are not important right now. Most important is our own preparation. So first is 10th Feb. Understood now? So here you check this one out. 6th Feb I am starting. So 6, 7, 8, 9. These 5 days maths will be full. Here also maths will be full. 4 days maths will be there. Got it? I hope everybody understood. Good afternoon, everyone. So please kindly check. A one maths book is there, check. So this is our format. This 1, 6, 7, 8, 9, 4 days maths massive revision we are going to do. Okay? Now here right now, our time slot is telling that third, fourth, fifth, 3 days last we are going to do science. Got it? In these 3 days, our total slot will be totally dependent upon those chapters which are difficult. Understand or not? So, environment chapter only one slot revision we are going to do. Okay. So here fifth we are going to do which chapter revision? Environment we are going to do revision on fifth. Plus we are going to do revision on control and coordination. Control and coordination. Plus we are going to do revision between carbon and its compound, because carbon and its compound one more time we have done, but one more last time we are going to do carbon and its compound. I'll tell you final part what and all we are going to do. So this is fifth slot. Fifth our target is this one. Understood or not? Third and fourth we are going to put full focus in today and tomorrow. Our full focus should be only in physics. Understood or not? So physics we have finished light mirror part yesterday. Today we are going to do what part? Refractive index, and then we are going to do lens part, lens related numericals, lens related some important questions. No, 12th class. Will Almira can you check Rita? Almira can you check? I sent you one screenshot. You check. This is for your right or any other? I hope you might have understood. Very good, Imanshu. Now look here. Are we ready for the class, please? So now look here. Today, without wasting time, we will go very fast because question answer sessions, fast paced revision we need to do. So this is our slot 6th, 7th, 8th, 9th. Full on maths we are going to do. 10th we will do maths, 11th and 12th. Understood or not? Then final 10th, 11th, 12th I am having conference. Okay, but from there also I am going to take your class. You will have class nearly 2 hours class. I am going to. Very good, Imanshu. So here, see, 2 hour classes will be there. That time also, I will give you more of work that time. You are listening or not? That time 10th, 11th, 12th, more of work I am giving you for practice. Got it? Now 13, 14, 15, 16, there will be no stoppage because full day we will have maths revision. Got it? So now we are ready for our work. Please get ready for our most important section today. So refractive index. In refractive index, we know that light travel from rarer medium to denser medium. So there are two actual mediums. So why we are dividing the medium? It totally depends upon the speed of light. So definitely when the speed will change, so medium will be definitely changing. Correct? So here speed change means medium change. So why? Because from one medium, if you are going to another medium, definitely we are expecting change in medium. Understood? Speed of light is changing. The change in the direction of light when it passes from one medium to another medium obliquely. Obliquely means by making an angle. Obliquely means by making an angle. So when you will be traveling from one medium to another medium, at the time of traveling from one medium to another medium, when there is a change in the speed, that is considered as what? That is considered as change in medium, that is oblique projection. Oblique projection means by making some angles. Oblique projection here means by making some angles. Understood? So change of direction of light when it passes from one medium to another obliquely is called refraction of light. In other words, bending of light when it goes from one medium to another medium obliquely is considered as what? Reflection, refraction of light. It is not reflection. Refraction of light. It is exactly considered as what? Refraction of light. Finally, what we are going to speak about it? It is considered as what? Refraction. Hello, Sophia. It is considered as refraction of light. One more time I am using the word. What word I have used? Refraction of light. I hope you might have understood this one. Now we are going to go for the last one. Now please pay attention here. So the angle of incidence, angle of refraction will be there. So here for refraction, what and all things are there? One last 1 minute, we are revising this part. I am making this video for you people. So refraction of light takes place when light rays enter from air into glass or from glass into air. The refraction from the light takes place at the boundary between the two media. Please remember this. The refraction of light takes place at the boundary between the two media. The refraction of light takes place yes. So the refraction of light takes place when light rays enter from air into glass or from glass into air. That means the light takes place, the refraction of light takes place at the boundary between the two media. At the boundary between the two medias. At the boundary, the refraction of light takes place at the boundary between the two medias. The refraction is taking place at the boundary between the two medias. Means air and glass, air and water, glass and water. Understood or not? Water and glass. So between two medias, at the boundary itself, refraction starts. Where is refraction starting? At the boundary between the two medias. At the boundary between the two medias. At the boundary between the two medias. Understood? Got it? At the boundary between the two medias. The angle between incident ray and normal point of incidence is called angle of incidence. So this is a different thing. The angle between the refractive ray and the normal at the point of incidence is called as angle of refraction. Understood? Now, if the refraction of light, the angle of refraction is usually not equal to angle of incidence. This is a different thing. See, you need to understand two different part here. So here, these are the two different things. Let's check this one out. So now please pay attention. When we are going from, understand one time. So this is most important. If it is rarer medium, you contact me separately. If it is a rarer medium and this is a denser medium, RD, this is denser medium. So when the light ray enters from rarer to denser, it will bend towards the normal. So here angle of incidence and this is angle of refraction. So angle of incidence will be greater than angle of refraction at that case. Quick short recap revision we must be doing. Angle of incidence will be greater than the angle of refraction at that case. Angle of incidence will be greater than the angle of refraction at that case. I hope everybody understood this one. Angle of incidence is greater than the angle of refraction at that case. Now second case, given the light ray will go from denser medium to rarer medium. So from denser to rarer, if it is going, then from denser to rarer it will go. Then here, this is incident angle. It will bend away from the normal. This is normal. The normal is always perpendicular to the surface. So here angle of incidence will be less than angle of refraction. So this is the two cases. Angle of incidence is equal to or greater. So these are the two cases. So whenever refraction happens, it happens at boundary between two media. So refraction occurs at boundary
between two media.
Boundary between two mediums. Boundary between two mediums. Refraction is occurring at the boundary between two mediums. Refraction is occurring at the boundary between two mediums. This you remember, please. So when somebody will be asking you when the diffraction is occurring, then what is our answer? It occurs between two medium. When medium change will be there, then refraction is occurring. Now next part. So speed will change. Now causes of refraction. So what are the causes of refraction? This is the most important part. I am putting here star mark for your remembrance. So please kindly remember this. This is the most important point. Please everybody carefully do this part. So please everybody carefully do this part. This is most important section, causes of refraction. What causes refraction? Causes of refraction. So causes of refraction. What are the reasons behind refraction? First part, the refraction of light is due to change in the speed of light. Understood. And refraction is due to change in optical density of medium. Understood. Change in speed of light. But this change in speed of light is occurred because of change in optical density. This also remember please. Change in optical density between the two medium. So definitely rarer and denser medium, optical density is the material intrinsic property. With this property only, they will be either allowing the light rays to enter inside. Understood? So only this is called as optical density. What it is considered as? Optical density. What is the name given to it? Optical density. So look here, this is exactly considered as what? Optical density. So what is optical density? Optical density means every medium like water, glass, kerosene, every medium will have some different type of properties. The property that is called as optical property. Understood? Optical property here means given any light ray will try to enter. Optical property here means given any light ray tries to enter from one medium to another medium, they will allow to enter. Like I am coming in your house. So you will allow, okay, auntie, you can come. But I'm seeing every place something, some hindrances there. Then what will happen? My speed of entering inside will reduce. Correct, na? My speed of entering inside will reduce. Drastically, my speed will reduce. So, if my speed will reduce, will I be able to enter nicely? No, I will not be able to enter nicely. That means my optical density is reduced. Understood not? No, my optical density is not reduced. My speed is reduced because of the hindrance provided by the particles. Understood not? So, optical density and mass density, they are different. Understood. Optical density and mass density are different. So that we have to remember. Now look here. So now we are going to remember this part that the refraction of light is due to change in the speed of light on going from one medium to another medium. So when light goes from one medium to another medium, its speed changes, and its change in speed causes reflection of light. So greater the difference in the speed of light in the two medium, there more will be bending. Understood or not? So the moment change on speed will be there, bending will be more. Understood or not? So this you remember, this is the second important point to remember. This is the catch point and very, very important. Greater the difference in the speed of light in the two medium, greater the difference in the speed of light between two medium, greater is the bending. Greater is the bending. And who is causing this change in speed? Who is causing this change in speed?
Medium, two mediums, one medium to another medium, and light is traveling to this long.
Ma'am, the session is recorded. Ma'am, Vishwa can return and see. Understood. So greater is change in the speed. So you need to check this one out. Greater the difference in the speed of light between two medium, greater is the bending. So when it will be greater? When optical density is highest. So greater is the difference between the optical density. Greater will be bending. Understood or not? So optical density of a material plays a very important role. Everybody pay attention. Optical density. So now understand one thing. Opaque object now, there are different type of objects. So like transparent object will be there, translucent object will be there, opaque object will be there. Opaque means wall. Wall never allow light to enter through it, correct now? So that means its optical density is at its highest. So if optical density is that much high, it will bend the light, but it will not allow the light to reflect. Understood? Will not allow it to do reflection. Refraction. Understood? Refraction means allowing the light to enter inside. Understood? But transparent and translucent material will at least allow the light to enter. Understood? But some will never allow, like wall, the screen. They'll not allow, they'll reflect the light. Understood not? So optical density is much highest. It will not allow. It will not allow the light to enter inside the medium. So when it will not allow light to enter inside the medium means we came to know only one thing. And that particular point is okay, fine. We are not able to go inside the medium. Speed will not be able. It will reflect, but it will not refract. It will reflect, but it will not refract. I hope you might have understood. Now, speed of light in air is 3 into 10 to the power. This is the next point. The speed of light in air, 3 into 10 to the power 8 meter per second. In glass, 2.8, 2 into 10 to the power 8. And in water, 2.25 into 10 to the power 8 meter per second. So this is the variation. Note down please. The speed of light in air is 3 into 10 to the power 8. The speed of light in water is 2.25 into 10 to the power 8. And the speed of light in glass is 2 into 10 to the power 8. The human body will reflect light or refract light. The human body will reflect light. It will scatter. The biggest word here is not reflect, it will scatter light. So the one which is having uneven body surface will scatter light. Understood? That's a very good question. So now please pay attention. When bending will be more? When the speed variation is maximum. Understood? Speed difference is maximum. That means what? Optical density is highest. Greater optical density. So let's note it down how this is happening. Now come on, go for it. Let's have a look in this. So now understand one thing. When bending will be maximum. Maximum bending. Maximum bending will occur when? Maximum bending. When maximum bending will be there. Maximum bending means refractive index more or high. High refractive index. Maximum bending means high refractive index. Next, optical density. Optical density of medium is high, then rarer medium. Understood? Next, speed will reduce more. Understood? So that means these are some of the most important parts. Speed will reduce. Speed will not increase. Speed will reduce. or speed will increase more. Both will happen. But here first part we are discussing when the speed will reduce drastically. Understood? Then bending will be maximum. So now just understand this. Now we are talking about rarer medium and we are talking about denser medium. Now this is the normal. Now the moment the light ray tries to enter,
it bends towards the normal.
so this is exactly angle of incidence. Now this is our normal. Now the light ray tries to enter and it bends very much high towards the normal. Usually its usual path was like this. Understood not? This is the actual path. Understood? What is the speed in vacuum? The speed in vacuum will be considered as 3 to 10 to the power 8. In medium, it is exactly 2.9. But for reference, we are taking it common as 3 into 10 to the power 8. Actually, in medium, it is more. So I hope you might have understood this one. So when you will be taking the bending, will try to go more near the normal. That means what? Optical density is maximum here. Optical density is here, it is maximum and here it is minimum. Now speed is high here. Speed of light is high. Speed is exactly high. The moment it enters, speed becomes low, decreased. Understood? Speed decreased drastically due to bending from the surface. Understood? So bending occurs at the surface. It will allow the light ray to bend towards the normal. Understood not? So bending is maximum. Bending becomes maximum. This is actually the bending. Understood or not? The moment drastically, the speed is reduced. The moment drastically, the speed is reduced. The loose, you understand, remember this part. I hope everybody might have understood this one. I hope till here everything is clear. Is it okay? So what is exactly the phenomenon here? The bending is maximum, optical density variation is more, speed is reduced, refractive index is highest. Understood? Because once the bending will be more, refractive index will be high. So this is exactly occurring in reverse case also. Reverse case will be what? Very high dense optical medium. The light is coming outside in a very less optical medium. So bending will be very, very high. So that time also bending will be more. But that time bending will become least. You need to remember this one. Yes. Second case is also possible. It's not like only one case is possible. Understood? Now you understand that if from a source of light, so this is highest optical density. High optical density is there. And from this high optical density, the light ray is making some angle and it is trying to come out. Understood? This is normal. The moment it will go towards the normal, so this is I. Now what happened? The bending is exactly now away from the normal. So it is coming from denser to rarer. High optical density to low optical density. The speed was less.
Speed, low speed, no.
Not here is high speed is there because then eventually it came up. So your angle of refraction is more. Angle of refraction is more. So now this will be bending away from the normal. Understood or not? So here also refractive index will change drastically. Understood or not? Everybody? So here also refractive index will become high. The reason behind is that now the light ray is exactly coming from a denser medium towards rarer medium. Understood? So definitely these things are much important to remember. I hope till here it is okay. Is it okay till here? So this is the next part. Now we are going to go for the next section. So now why a change in speed of light causes refraction of light? This is the question. So please, these questions are most easily asked questions in CBSE. Don't write like the full story. We have written as a para, but I am going to underline that part. You are going to write it as point-wise concessions. Understood? Or not? So now look at a beam of light is made up of tiny waves. So we know that light is having two characters. One is material particle. When the light moves with the help of material particles, or when the light is moving with the help of waves. So when material particle, when light will be taking, then it will move in straight line. Understood? Wave means it will be moving in transverse form. Understood or not? So here please kindly take care. A beam of light is made up of tiny waves. Understood? So when the beam of light consisting of light waves and traveling in certain medium falls obliquely. Obliquely means making some angle. Oblique projection means making some angle. What is the meaning of oblique projection? Making some angle. So when they will be making some angle on the boundary of another medium, then one part of the light will enter into another medium first and its speed changes first. So all the part will not enter. One will enter first, after that followed by the second one and followed by the third one. So see, like you are running in open field and the moment you are going inside someone's house, will you enter with the same speed? No, no. All of 3, 6, 7 people are there. We will enter one by one. So definitely first one will enter, then second one will enter, then third one. So all will not enter at same time. So here the same thing is there. Then one part of the light will enter into another medium first and its speed changes first. But the rest of the wave enter the other medium a little later and hence its speed changes a little later. The fact that speed of light wave on one side of beam of light changes a little before the change in speed of light on the other side causes the direction of light. Understood? And this change the direction of light is called as refraction of light or bending of light. So you can write in your own formatted statement. So please, you just write the most important. Change in speed of light will be there in the medium. Understood? Remember this one. Then one part of the light wave will enter and into the other medium first, and after that, the speed will be changing. That's the most important point. Note down, please. Everyone get ready for the next part, please.
Okay.
Today they are getting sleep over. I need some questions. It's like for people, nothing to be done. Before exam, they want important question to study. This is called a sudden wake up of trauma. Are you all ready? Now look it. So this is one part we have done. I gave you enough time to write down whatever work is there you have done. Now are we ready for the next section, beta? Now this is exactly what this part is. See, when you will be talking about this is called as lateral displacement. Understand now? So why this lateral displacement? Lateral displacement is that part where see no that is lateral inversion, that is inversion and this is displacement, because when they will be talking about lateral displacement, can you check this part out? So actual bending is exactly what is occurring, actual bending. So here the light ray was supposed to travel in this path. See, the path was exactly what it is called as lateral displacement. See, this is exactly supposed to go like this, correct? Hmm? And here also it was supposed to go like this. But did they went like this? No. They went with making some angles. So definitely the displacement between the actual one and the one which is exactly going to be done after bending will be called as lateral displacement. What it is called as? Lateral displacement. So lateral displacement is again the right side, therefore the direction of light changes or bending on entering the glass slab. So since the speed of left side of the beam of light increases little before the right side, so therefore direction of light changes. Understood? And they will be causing refraction. So optical rarer medium and optical denser medium. So some mediums are optically rarer and some mediums are optically denser medium. So now let's have a look about optically rarer medium and optically denser medium. A transparent substance in which light travel is known as medium. Air, glass, plastic, water, kerosene, alcohol, all are examples of medium. So different media are said to have different optical density. I told you about optical density in the beginning itself. A medium in which the speed of light is more is known as optically rarer medium. But where the optically rarer medium, the speed will be more. But in denser medium, the speed will be less. I told you, na, where material particle will not allow to enter. That means they are denser, and the speed will become less. So the speed will become less. So they will be considered as what? Optically rarer medium. That's most important part. Please check this one out. Now, a medium in which the speed of light is less is known as optically denser medium. Glass is an optically denser medium than air and water. So now the speed of light in water is 2.25 into 10 to the power 8, which is less than air but more than glass. So now we are going to talk about when the ray of light goes from a rarer medium to denser. Already we know this, that the light ray will bend towards the normal. Understood? and change in medium will be there. Already we know about this, and this is when the light ray will move from denser medium to rarer medium. So this also we know. The case of light going air into glass and again into air. So this part we are going to see and we are going to analyze this. So this part is called as lateral displacement. Now let's have a look and let's have a discussion about this part of change. Now please take care of this. The angle which the emergent ray makes with the normal is called as angle of emergence. So see, this is emergence. Can you see? This is the usual path of light. Please check this one out. See, this one is the usual path of light, but it was exactly not followed. Everybody, those who are present in the group, can you say hi to me fast? So now, but what happened here is they went bending. One time bending is here, and then after this also it bent here. So this variation is called as lateral displacement. This variation is called as what? Lateral displacement. So this variation is considered as what? Lateral displacement. So this is considered as lateral displacement. This will be coming as angle of incidence. This is refraction angle. This is also refraction angle, and this is called as angle of emergence. So we must remember few points. Now look here. The normal is called as angle of emergence since the incident ray and the emergent ray are parallel to one another. So the angle of emergence is equal to angle of incidence. Always remember, when the light ray will be coming out, everybody check how many of you are live or not. Just give me a clear conclusion here. So this part you must remember that angle of incidence will become angle of incidence will become angle of emergence. Angle of incidence will become what? Angle of emergence. Incidence will become angle of emergence. When the light will be exactly coming out. When the light will be parallel and it will be coming out from the medium. I hope you might have understood this one. Come on, say children, everybody online. How many of you people are online? Take class, take class, take class. When I'm discussing, nobody is in the class. Where are the students? Maha, Sophia, Sanjay. Quickly respond. Did you got this point? Angle of incidence and angle of refraction. So when angle of incidence means when the light ray is coming from one medium, goes another medium and then comes out. So here angle of incidence will become equal to angle of emergence. Understood? You remember this one. Incidence will become equal to emergence. Understood? And this variation is called as what? Lateral displacement. This variation is considered as what? Lateral displacement. What it is considered as? Lateral displacement. Hi, beta. So this is considered as what? Lateral displacement. This is most important. Till now, we came to know, can we make a conclusion here? So what in all conclusions are here? Can we check one time? So we have learned some very important things here. The case of light falling normally. When the light will fall normal, then what special will happen? Nothing. It will retrace its path. So no bending will be done. Incident angle is considered as 0. Nothing is there in that case. Yes. So bending is not at all done. Understood or not? So it will just go and come out. So it will exactly come out. If it is no angle. So angle of incidence will be 0 degree. Understood? If the light ray will be falling normal. Understood? If the incident ray fall normally, is the surface of the glass slab, then there is no bending of the ray of light and it goes straight. Effect of refraction of light. The refraction of light produces many effects which can be easily observed in our day-to-day life. We will not describe some of the important effects of refraction. This is due to refraction of light. What and all are the effects? First effect is, can we see the stick bending? Come on, can we see the stick bending? So this bending of the stick is again due to the refraction of light. This is one is real and one is apparent. So this one is the real one and this one is the apparent. Understood or not? So here, which one is oblique projected? So here you will see that definitely this angle bending. So only when what you call spoon or something will be inside glass, you will be feeling that it is bended. But once it will come out, class 12th is having classes. Because yesterday also you can go in the class and you can see whatever classes I have taken. All the maths classes there. So now please pay attention here. This also an object placed under water appear to be raised. This is because of that only. Now here water appear less deep when it is actually. Swimming pool you will be feeling like the water is very less. But is it actually less? No. In swimming pool the water is not at all less. The water is actually high. But it will look like that because of what?
Refraction of light.
Understood? So apparent and real one will be different. Can we check here also? So when light, water will not be there. So here can we see the coin is exactly looking like raised. But actually the coin is on the bottom, but the coin will be exactly looking raised. So when appears raised, when visible, same position will be there, apparent and real will be. So if you will see like normal, you will feel that the water is less, but actually depth is more. Understood? So this again will be done because of its refraction of light. Refraction of light. So letters will also be highlighted because of refraction of light. So law of reflection of light, can we go for it? Because we are going for a last short revision. So we are going to discuss about this. So according to the first law of refraction of light, the incident, the refracted ray and the normal all lie at the same plane. So this is considered as law of refraction of light. Next part is the angle of incidence, angle of refraction. The ratio of sin I by sin R will be constant. This is most important. Sine of angle of incidence by sine of angle of refraction, that will be equal to constant. This is one of the most important part. Can we check this one out, please? I hope till here it is okay. So this is again most important part. Now look here, angle of incidence by angle of sine of angle of incidence by sine of angle of refraction. So now we are going to understand the second part. This constant is called as refractive index. The value of constant for a ray of light passing from air to a particular medium is called as refractive index of that medium. And refractive index is denoted by symbol N. Understood? So where sin I is sign of angle of incidence in air by sign of angle of refraction in medium. Just short term division we are doing. So now we will go for the next part. So please note that since that refractive index is ratio of, so it will not have any unit. Refractive index is not having any unit. Understood? So the refractive index of medium gives an indication of light bending ability. So if somebody will be wanting to know that the light is getting bended means refractive index is going to play the crucial role. For example, the refractive index of glass is greater than refractive index of water. That means bending from air to glass is more in compared to that of bending from air to water. Are you understanding? So refractive index is higher for glass than in water. Understood? How this is happening? Let's have a look. See, understand. A simple part I am going to explain. This is glass and this is air. Now this is air and this is water. The speed of light in air is, given it is entering, the speed of light in air is 3 into 10 to the power 8 meter per second. But the moment it is entering, it will bend. So speed of light in water is 2 into 10 to the power 8 meter per second. So speed reduced, understood. But here the speed of light in air is 3 into 10 to the power 8 meter per second. Here it bent like this. It will become 2.25 into 10 to the power 8 meter per second. So where the bending is exactly visible more, where bending is more? Bending is more in glass.
Because it is closer to.
See, speed changes. Speed is more. Speed of light is more in water than in glass. So bending is more where? Glass. So since bending is more in glass, refractive index of glass is more than refractive index in water. Understood? So speed is here more and his speed changes less. So here bending is more, here bending is less. You have to remember this. One more time watch this video for a perfect understanding. I hope you might have understood this one. So one more time try to understand this part and check. I hope you might have understood this one. So 2 into 10 to the power 8 meter per second, 2.25 into 10 to the power 8 meter per second. So speed is here for glass, it is less, but speed in water is more. So here the variation is more here, so bending is more here. So I hope you might have understood this one. Is it done? So this is exactly the most important part we have done. So see, so this was the clarity we were needing to understand about refractive index. For refractive index, what is the unit? No unit, because it is in ratio form. So since it is in ratio form, so refractive index of water is less in compared to that of refractive index of glass, because bending is more in glass than in water. Now, sample problem. A beam of light passes from air into a substance X if the beam is incident 72 degree and 40 degree. So they have given the value. We can be able to find the refractive index. Sin I by sin R. Come on, go for it, please. Done, beta? What is the formula? I gave you time to solve. Sin I by sin R. Refractive index will be written as what? It is not a big shot. It will become sin I by sin R. So what is I? Incident will be sin 72 degree by sin 40 degree. Correct? So definitely 72 degree value and 40 degree value is, and 72. They have not given 72 degree value. This 40 degree value is given. Okay, so just sin I by sin R, you remember, like this only we are going to solve. So now let's see, go for this one, refractive index and speed of light. So definitely when refractive index will be more means speed of light is less. So because speed of light is more, refractive bending is, see, we need to understand the material through which light travel is called medium. Light refracted is going from one medium to another because the speed changes. Slow down of speed due to this refractive index can also be written as ratio of speed of between two mediums, correct now? So here only one thing, we must check this part out. This is reading scale. The refractive index of medium 2 with respect to medium 1 is equal to ratio of speed of light in medium 1 by speed of light in medium 2. This is exactly written. This is the way to write, okay? This is the way to write. So this is the way to write refractive index of medium 2 with respect to medium 1. Got it? Now come on, note down this one.
For that 72, for the 1.8 is
How much it is coming? So the refractive index of medium 2 with respect to medium 1. So this we are exactly going to read like this. But once we are going to check this one out, come on, check this. So see how we are exactly writing this one as. So writing part one more time because after this we will solve questions. This can be written as speed of light in medium 1 by speed of light in medium 2. And how we are writing? Medium 1. How we are writing? 1 and here medium 1 and medium 2. But how we are reading? Refractive index of medium 2 with respect to medium 1. Refractive index of medium 2 with respect to medium 1. But we are writing speed in medium 1 by speed in medium 2. So again see refractive index of medium 2 with respect to medium 1. We are reading like this and writing like this. Understood now? So refractive index of medium 2 with respect to medium 1. Is it okay? Understood? Now we will go for the next one. Are you ready for it? So can we go for, okay? So this is exactly, please note that symbol 1, this means that refractive index of medium 2 with respect to medium 1. Understood? So light entering from medium 1 into medium 2. But refractive index, how we are reading it as? Medium
1 by medium.
See, so when light is going from one medium to another medium, then the value of refractive index is called as relative refractive index. There are two refractive index. Now refractive index can be absolute refractive index and relative. Note down in short, there are two refractive index. One is absolute refractive index and another one is relative refractive index. First one is absolute refractive index. Second one is relative refractive index. Absolute refractive index and relative refractive index. Absolute refractive index and relative refractive index. Absolute. So two are there. Absolute refractive index and relative refractive index. So their simple medium 1 to 2. So how we are going to read it as? First, relative refractive index. When two different medium will be there other than air, then it is called as relative refractive index. Means simple water and glass. So here water and glass is there, kerosene and alcohol is there. So it is not, air is not taken as one of the medium. Understood? Then it is called as relative refractive index. When two mediums are taken like water and glass, kerosene and glass, turpentine oil and glass. So means air is not taken as medium. Understood not? So air, but when we are taking air as one of the medium, fixed medium, then it is called as absolute refractive index. In absolute refractive index, air is taken as one of the medium. But in relative refractive index, two different mediums are taken rather than air. So these are the two different type of refractive index. I hope you might have understood. The light is going from vacuum to another medium, then the value of refractive index is called as absolute refractive index. So here we have understood two refractive index are there. One is considered as absolute refractive index, another one is called as relative refractive index. So absolute refractive index means air will be considered as one of the medium. Air to glass, air to water, air to kerosene, air to diamond. So that type mediums are always considered as absolute refractive index. Relative refractive index means when two different mediums are there. So we will check medium speed of light in vacuum, speed of light in medium. So the ratio of speed of light in air to the speed of light in medium is called refractive index. This is called as what? Refractive index. Absolute refractive index. Relative part we have understood. So now we have finished refractive index part. Understood now? So refractive index section is over. Now we are going to start lens. Understood? So in lens, because mirror part, yesterday 2 classes of mirror we have done. One basic section we have started, and then mirror, all the 6 cases of concave mirror we have done, and then convex mirror we have done. Now we are going to talk about lens now. Understood? So we'll take a break and then we will start.